Hi class, welcome back. So let's talk about truss analysis method of section. So last lesson we talked about the method of the joints. So today we will talk about method of section. So either method should be able to solve the problem, but the method of section we are going to discuss today, it's much more easier, especially you are going to analyze a more complex structure. Okay, like in the real world we have trusses, like to formulate a crane, a power tower, which is pretty well complex. So that's when we need to use the method of the section. So what are the steps for the method of section? So as you already can tell from its name, we need to cut a truss into the different sections. So our first problem becomes decide how to cut the truss. Okay, it will be based on where you need to find the forces, okay, and also where the number of unknowns does not exceed 3. Okay, so we definitely need to cut in a section, and after cut we can get the exact location we want to find the forces. And also we need to consider if we cut a section, cut into two more section, or this section has more than 3 unknowns. If it has more than 3, which means we can now solve a problem. And then, okay, decide which side of truss, okay, is easier to analysis. So usually we select the side, either left side, right side, upper side, down side, with less number of the members. And then we need to draw free body diagram of the trusses. Convert its support into free body diagram, whether it's a pin, whether it's a roller. Okay. And then what should we do? Okay, we need to draw FBD of the side chosen, okay, from step 2. And also we need to indicate and know the forces in member. And also we'll assume everything is positive. Okay, let's start with our assumption. And then we need to apply equation of equilibrium to the free body diagram in step 4, okay, to solve for unknowns. Okay, the equilibrium is sum of fx equals to 0, sum of fy equals to 0, sum of the moment on any point is 0. Okay, that's the step 4 and 5. Let's see an example. So we have the truss, and also AA is a pin, G is a roller. Okay. And you need to find the force being the members in KG, KD, and CD. So first you need to decide which the location of a cut. So we can cut here. So by cutting here, we can new KG, KD, and CD. Okay, we can solve those three forces, which is exactly what we are looking for. And after the cut, should we work with the left piece or the right piece? So for this problem, our principle is always to select a piece with less number of the members. So we select left piece. So, but for this one, if you select right piece, it shouldn't be much more complex than selecting the left pieces. So, and the answer should be always the same. It doesn't matter if you select right or left. It only matters the calculation process. Okay, and for this then we need to determine the support of the action at A, and then apply equation of the equilibrium to find the force in KJ, KD, and CD. Let's say first, let's analyze the entire truss to find the reaction at A. So the first equation we use is sum of fx equals to 0. In this problem, we only have ax, which is on the horizontal or in the x direction. So we can easily get at sum of fx equals to 0, ax equals to 0. Okay, so we know the ax is just 0. And then we can calculate the moment on point G to find the ay. So it will be ay times 12, which is distance from action line of the ay to point G, which is 12 meters. And also it's a positive, and also for the 20, distance to point G is 10, 30 is 8, 40 is 6. We times the distance with corresponding force, we can get equation, and then we can solve ay 55.7 kilonewton. And then let's look at the left piece. Let's draw a free body diagram. Okay, because the ax is 0, we are not putting the ax on this figure. We have ay 56.7 and the force on point B and C respectively. So we have three unknowns, fkg, fkd, and fcd. And for the left piece, we also have three equation of equilibrium, which means we can solve this problem. So what we do first is let's take a moment upon point D, okay, because this is, if we take a moment on point D, the FKD and FCD, the direction of the line are both on the D point. D point are on the action of the line of FKD and FCD. So which means FKD and FCD, they have 0 moment on point D. So the only thing unknown is FKG. So which means if we take a moment on point D, at this moment we can solve the FKG directly. So here's the equation, and after use a calculator, we can find FKG is negative 66.7. Okay, and it should be a compression, okay, based on what we discussed before. And then use the x and y direction equations of the equilibrium, we can find the sum of Fy equals to 56.7 minus 20 minus 30. Our assumed positive direction is upside, and also minus 3 over 13 times FKD equals to 0. Okay, and then we can use a calculator. We solve FKD equals to 8.05, and there is a tension. And also, sum of the Fx equals to negative 66.7, which is the FKG, plus 2 over 13 times FCD equals to 0, and then we can solve the FCD. Okay. At this moment, we already solve FKG, FKD, and FCD. And we know it's both magnitude and also whether it's a compression or tension. In your homework, in your exam, please don't forget to put a parenthesis to indicate whether this force is a tension or compression. Example 2, okay, here is a truss. You need to find the force in members ED, EH, and JH. So before, look into my solution, so you can pause this video a little bit and think about where to cut. Okay, that's the first question we need to think when we are dealing with the method of the section. Okay, I hope you have the same answer as me. You need to cut at this location, because after we cut here, we can get we can solve FD, ED, FEH, and FGH. And then we should select the left section, okay, for this problem, because we have less number of the force and less number of the members, okay. And also, if you select the right side, the answer should be same. If your calculation is correct, okay, the only difference is the number of times you spend for the calculation. Okay, if you don't trust, you can work with your friends. Like you work on the left side, your friends work on the right side. Your answer should be the same. Okay, but your people select working on the right side definitely will spend more effort. Then draw a free body diagram of the left section. Apply equations of the equilibrium. Okay. So let's solve the F reaction at the A point, at the F point. Okay, F is a roller, only has Fy. So let's take the whole truss as a whole. The moment on point A is Fy times by 4 plus 40 times by 2 plus 30 times by 3 plus 40 times by 1.5. So we can solve Fy equals to 57.5. Then let's draw the left section piece. Sum of the FME equals to negative 57.5 times by 2 plus FGH times 1.5 equals to 0. We can solve the FGH. And then we can use sum of Fy equals to 0. We can solve the FEH. And we can also solve the FED by using sum of the moment on point H equal to 0. Okay. So that's pretty much for today's lecture. So also, please start working on the homework. I believe today's lecture and the last lecture require a lot of exercise. Okay, that's pretty much for today.